Okay, so intensity due to the uniform spherical shell. Okay. So if I am taking the spherical shell, mass of shell is m. Radius r. Then intensity at a distance from center. So we want to find the intensity due to the spherical shell. I am writing here uniform, but sometimes they don't give the uniform, so we have to assume what it is a uniform shell. Uniform means what? Density is same everywhere. Okay, so number one, outside the shell. So we want to find the intensity at the point P and the center is C. From the center distance of the point P they have given X. So one thing I said in the gravitation in the first lecture, for to find the force between the solid sphere and the hollow sphere, we can replace the sphere by the point mass and we can assume at the center. So same way we can do here. We want to find the intensity at P and P is at a distance X from the center. This spherical shell, to find the intensity outside, this spherical shell I can assume as a point mass at the center. Now point mass is at the center. What is the distance of the point P? X. Okay. Then what is the intensity due to point mass? Gm by x square, Gm by r square we have learned. So similarly here we can say intensity at P, that is equal to what? Gm by x square. And what is the direction? Direction is towards the mass. Direction is towards the mass, so we will get direction is what? Towards the center. Okay. Everybody got? Second we can say on the shell. On the shell means x is equal to r. Then intensity what we will get? Gm by r square. Okay, so outside and on there is a no problem, directly we can replace the spherical shell. Even solid sphere also same result we will get. Okay, but inside result is a different. Inside the shell intensity will be zero everywhere, not only at the center. Inside the shell intensity will be zero everywhere. So outside and on, everybody clear? Now inside the shell, inside the shell means x is less than r. Then intensity will be zero everywhere. So, okay. This result we got by using, we can say either by the Gauss law, we can say, otherwise we can say by the integration. Simple way you can understand. Suppose this is the shell, okay. This is the center of the shell. I want to find the intensity at any point P, that is inside the shell, okay. We have got the result by using the integration or the Gauss law. But simple way I am saying, suppose I am taking the shell and I want to find the intensity inside at the point P, okay. So I can divide this shell by the two parts. One part is the upper part and other is the lower part. Okay. You can see upper part mass is lesser, lower part mass is more. Okay. Intensity at the point P I want to find. So due to the upper part, Due to the upper part, what will be the direction of intensity? Mass is above. Mass is above. So intensity will be always towards the mass. So due to the upper part, intensity you will get above. And due to the lower part, intensity you will get below. So both intensity are lower part and upper part intensity are what? Opposite direction. Okay. Because lower mass is below. So that's why intensity is always directed towards the mass. Okay. Now you can see here, upper part mass is lesser, lower part mass is more. Okay, so mass more, intensity will be more. But what is the like here, why the intensity is 0? Upper part mass is less, but distance of the point P is also less. Distance of the point P from the upper part is less. Distance is less, mass is less, so intensity is what? Gm by r square or gm by x square. So upper part mass less, so distance less, so gm by x square will be equal to the lower part. Lower part mass more, but distance of the point P is also more. Okay, that's why they will cancel each other and I1 and I2 will be equal. So that's why everywhere, any point, intensity inside the shell, what we will get? 0. Okay, everybody got or not? So directly remember the result that intensity inside the shell will be 0. So suppose I assume any mass m, mass of the shell I am taking capital M, and any mass m I assume inside the shell. Okay, mass of the shell I assume capital M, and inside the shell I assume the particle of mass small m. What is the force applied by the shell on the mass m? What is the force applied by the shell on the mass m? Force applied by the shell on the mass m. So what we learned, intensity definition, I is equal to vector F by m, or F I said m into I. So due to the shell, what is the intensity inside? 0. Due to the shell, intensity inside is 0. Now intensity is 0, so how much force mass m will experience? 0. So means shell will not apply any force on the mass m. Everybody got or not? Anywhere you are putting, it will not experience any force due to the shell, or shell will not experience any force due to the mass m. Okay. Now graph. So here I want to plot the graph between the intensity and the distance from the center. Okay. Audio not miss, some net problem is there, I think. Here, this side, from this side, I think problem is not there. Somebody is getting, somebody is not getting. So check your internet connection. Okay. So origin I am taking the center. From center to the R distance means you are inside. Center to the R means inside. Inside means intensity inside the shell is what? 0. Okay. So inside the shell, intensity 0 means from the center to the shell you will get 0. When you reach on the surface, intensity you will get gm by capital R square. So as you reach on the surface, intensity will become gm by capital R square. Okay. And as you go outside, then what is the variation? Outside variation is I is equal to gm by x square. So g and m is constant, then I is inversely proportional to x square. Okay. So means rectangular hyperbola. So inside 0, as you reach on the surface, gm by capital R square, and outside variation is the rectangular hyperbola. Everybody got? Or they can give this option in the negative direction. Okay. So either they will give above option or below option. Okay. But suppose both option is there. Which option you will go? If they have given both option, then which option you will? So pattern is same, but if they have given the both option, then we will go to the second lower one. Reason is what? Intensity is in the opposite direction. Like if the center is here, so intensity will be in the negative direction. Negative direction, that's why we have to take the second one. Getting or not? So if both option is there, rarely they will give. Both option is there, then we will go to the lower one. Otherwise, either they will give this one or they will give this one. Okay? Oh dear, my video is not off. If my video is off, then how the other will get the videos. Completed. Now next is the intensity due to solid sphere. So if they are saying the solid sphere or they are saying the sphere, then we will consider the solid sphere. For the shell particularly or the hollow sphere, they will mention is hollow sphere or shell, they will mention. If they are only mentioning the sphere, means we have to consider the solid sphere. Okay. So first one is the outside. X greater than R. Same result you will get. So outside and on, same result. Then I is equal to what? G m by x square, and the direction will be towards center. On the sphere, that is x is equal to r. Then intensity, what you will get? Gm by r square. Okay. Second graph, once same graph. Second graph, what I made the same graph, but if the both option is there, then we have to go to the second option, because the direction of the intensity is in the negative x. Why? It will be always towards the center. So center I have taken origin. So direction of the intensity will be towards origin, means negative direction. Negative direction. So intensity we will take negative. Okay. Third one, like inside the shell, inside the sphere. X less than R. Okay. Inside the result is different for the shell. Outside and on, same result, whether it is a shell or it is a sphere. But inside shell intensity is 0. But for the sphere, you can think I want to find inside the sphere. Okay. At the point P. At point P is at a distance x from the center. Okay. I can assume this one sphere of the radius x. Okay. If you think, if you see the green sphere, point P is on the surface of green sphere. Point P is on the surface of green sphere, and point P is inside the white shell. Inside the white shell, you can think P point I am taking. I have made the sphere of the radius x. Now point P is on the surface of the green sphere, and it is the inside of the white shell, because now I am splitting this sphere into the two parts. One is the green part is the solid sphere. When you remove it, then remaining will be the hollow, remaining will be the like thick shell, you can say. So point P is on the surface of the green and inside of the white shell. Due to the shell, what is the intensity inside? 0, means outside shell no contribution will be there. White shell no contribution will be there in the intensity. But at point P, there is an intensity due to the green solid sphere. That's why result will not come Gm by capital R square or Gm by x square. Getting my point or not? Because here inside green shell mass will be different. Okay, we can derive, but derivation not important. Then intensity at point P, what we can say? I is equal to G M X by R cube. Okay, like in the electrostatics, you will learn G you will replace by K, M you will replace by Q. So K Q X by R cube. Maybe somebody remember that formula. So intensity at a distance X from the solid sphere inside what is the variation? Gmx by R cube. If you are getting confused, means most of the formula we have learned R square. So R square or R cube is there. Then you can think dimensionally it has to be the Gm by R square. So one distance I am writing in the numerator. So that's why we have to take R cube in the denominator. Okay. Completed. Everybody got? So what is the intensity inside at the center? So intensity at center is what? Because at center X is equal to 0. So in the case of solid sphere, intensity we are getting 0 at the center only. But inside the shell, we are getting the intensity 0 everywhere. That is the difference. Inside the shell, intensity is 0 everywhere. But inside the solid sphere, we are getting the intensity 0 only at the center. So outside and on variation is same, only inside variation is the different. Okay. Now the graph. So inside what is the variation we are getting? I is equal to G M by R cube into X. Okay, G M R, that is a constant. So I is equal to Cx. I is equal to constant into X. I am plotting on Y axis. So we will get what? Y is equal to Mx. Y is equal to Mx is the straight line passing through origin. So there shell we got the intensity 0, but here we will get the graph straight line passing through origin. So till you are inside at center intensity 0, from center to the surface you got Gm by R cube into X, means Y is equal to Cx. On the surface you got Gm by capital R square. Outside variation and on variation is same. Outside variation what you will get? Rectangular hyperbola. This graph is very important because the same graph you will get in the electrostatics, electric field due to the solid charge sphere. Same graph you will get in the magnetic field due to the current carrying wire or the cylinder. So in the need they are the 2 times. Okay, so this graph you have to remember because 3 places we will get this graph. Or if they have given below one, so then you can go through this one. Okay. Completed. So that is the intensity due to the solid sphere and the spherical shell. Okay. Same way, if they are giving the both option, then we will go to the negative one. Will it touch the x-axis, sir? A rectangular hyperbola, ever it is touching the x-axis. You have learned in the Boyle's law. So many places you got the rectangular hyperbola graph. Rectangular hyperbola means y inversely proportional to x square. Y inversely proportional to x or any power. If you are putting the y0, then it will touch the x-axis. So y you will get 0 when x is equal to infinity. Can you reach to the infinity? Never. So rectangular hyperbola will never touch the x-axis as well as y-axis. Okay. Okay. So what is that problem? Thick spherical shell we have of mass m, inner radius I gave r1 and outer radius I gave r2. Then we have to find the intensity at a distance x from the center. Okay, I'm giving the option. So I have given the thick shell, inner radius is r1, outer radius is r2, and mass of the shell I gave m. Now I am asking the intensity at a distance x from the center. First option what I gave, I is equal to 0 when x is less than r1. So first option you can check, x less than r1 means where is the point? Inner radius is r1. X less than r1 means point is inside the shell. Inside the shell, what is the intensity? 0. So that's why first option is right. Okay. Second option I have given x greater than r2. X greater than r2 means point is outside. Point is outside because outer radius is what? R2, and it is a more than R2 means point is outside. When the point is outside, what we can do? We can replace the shell by the point mass and we can assume at the center. So what is the intensity you will get? Gm by x square. That is also correct. Third option what I gave, x is between R1 and R2 means x is more than R1. More than R1 means it is outside this shell, outside this hollow part. More than R1 but less than R2. More than R1 but less than R2 means somewhere here inside. Somewhere inside means it is not inside, it is not outside. Okay, so we will get intensity, some intensity we will get. Getting or not, because it is not the inside. So that's why I will not be equal to 0. So the third is also correct. That's why answer is what? Fourth one. Everybody got or not? Okay. First option, x less than R1. X less than R1 means point is inside the shell. Inside the shell, what is the intensity? 0. So first option is correct. Okay. Second option, what I gave? Second option, x greater than R2. X greater than R2 means x we are measuring from center. Greater than R2 means it is somewhere outside. Outside, what we can do? We can replace the sphere or the shell by the point mass and assume at the center. Okay. So outside, what is the intensity? You will get Gm by x square. So second option, what I gave, Gm by x square. So outside point, it is right. Third option, more than R1. More than R1 means less than R1 inside. More than R1 means outside this part. Outside this part. when you are outside this part but less than R2, means you are not totally you are not outside and you are not inside, you are somewhere in between. Okay, why? Greater than R1 but less than R2, less than R means you are not going out of the shell also and you are not going in of the shell, so means somewhere you are in the thickness of the shell, thickness of the shell. So you can assume this white shell. For this white shell, some green part is inside, some green part is outside. Some green part outside, due to that intensity will be 0, but some green part is inside also, due to that it will have some intensity. So in that material we can say, or inside that thick part, intensity will not be 0 because point is not inside the shell. Getting my point or not? Calculate, we can calculate. But we have to take the mass density and all. It will be little bit complicated, but we can easily calculate. Everybody got? Now next is the null point. Sir, for inside the shell, x greater than r or x less than r. X less than r. Shrikara, x less than r. Okay. Means less than radius, distance we are measuring from center. Now distance is less than the radius. It means what? It is not, it is what? Inside. If the distance is greater than radius, means you are outside. Because x we are measuring from center. Okay. Now what is a null point? So null point is what? We will learn the null point in the 3 places. Here gravitational field, then we will learn in the electrostatic field, and then we will learn in the magnetic field also. So what is the basic definition of the null point? We can say the point where the net field or where the field is 0. If I am talking about the null point of the gravitational field, then we can say the null point of gravitational field means the point where the gravitational field is 0. If I am discussing the null point in the electrostatics, then a null point is what? The point where the electric field is 0. If I am discussing in the magnetism, then what is the magnetic null point? We can say the point where the net magnetic field will be 0. All these 3 you will learn. Okay. So null point means basically field is 0. Okay. Now in the gravitation, when I am saying, so the null point is what? The point where the gravitational field intensity is 0. So if I am putting any mass on the null point, if I am putting any mass on the null point of the gravitational field, so if I am putting any mass at the null point, so what is the force it will experience? So what is the definition of null point? Intensity is 0. So when I am putting any mass at the null point, how much force it will experience? 0. It will experience 0. Okay. So at the null point, any mass will not experience any force. Similarly, in the electrostatics, when we are putting any charge on the null point, then that charge will not experience any force. Okay. Similarly, if I am putting any magnetic isolated pole, if we are putting the isolated pole in the magnetic null point, then that pole will not experience any force. Okay. So different definition is the same, but like electric field, then we will say the charge, magnetic field, then we will say about the pole, and gravitational field, we will say about the mass. But basic definition of the null point is what? The point where the net field is 0. Getting my point or not? Gravitational null point means net gravitational field will be 0. Okay. Okay, so So any mass does not experience force at the null point. So because here I am discussing about the gravitation, so I will deal with the mass. In the electrostatic, they will deal with the charge, because charge will not experience any force at the null point of electric field. Okay. Completed. Now suppose I am taking the two masses, point mass m1 and m2. They are at a distance r from each other. How many null point you can get? In this case, how many null point you can get? Tell fast. How many null point we can get when the two masses are there, m1 and m2, and no any other mass is there? Then how many null point we can get? 1, 2, 3, infinite. Options I am getting. First one said 1, then other boy said 2, then next 3, then 4. Okay, you are giving the options or you are saying the answer? All the 4 answer is different. First boy give the answer 1, second give the answer 2, third give the answer 3, fourth give the answer infinite. Okay. So answer is what? 1. We will get the only one null point in this case, one null point, and that will be in the infinite null point. How you will get? So here we will get the one null point. Like in the case of electrostatics charge may be, both may be the positive charge, both may be the negative charge, one charge may be positive, one charge may be negative. So in the case of electrostatic, we can get the null point outside the charges also. Like suppose I put one charge I put here, one charge I put here, charges are positive and negative, then I can get the null point here also, and I can get the null point here also according to the magnitude and the sign of the charge. So we can get outside the charges also null point. But in the case of gravitation, always we will get the null point between the masses. We will always get the null point between the masses. We will not get the mass null point right of the both mass or left of the both mass. Because gravitation, both mass will be mass positive, negative is not possible. Na? Mass will be always positive. Getting my point or not? So in the case of gravitation, we will get only one null point between the masses somewhere. Okay. And you can check also, like suppose I am checking here at any point P. I am asking what is the direction? What is the direction of intensity at P? So due to the M2, what is the direction of intensity at P? Towards the point mass. Towards the point mass means I2 direction is towards the M2. Due to the M1, what is the intensity direction at P? Towards the M1. So that is also towards the M1. Now you can see both intensity are in the same direction. Both intensity are in the same direction. So summation of two positive quantity will never cancel, never zero. So I1 plus I2 will not be zero. If you are taking the point P left, then intensity direction you will get right. So they cannot be zero outside the both masses. Okay. Up or down. Up or down also we cannot get, because the intensity direction will be like this. When intensity direction is like this, these two vectors will never cancel each other. So we cannot get the null point. I am talking about the two masses. Okay. Then they will not cancel each other. So here also we will not get. So only one possibility is there, somewhere in between. Okay. So suppose I am taking any null point like here. So in between what will happen? Suppose at this point, direction of intensity due to M1. Direction of intensity due to M1 will be towards M1. That is I1. And direction of intensity due to the M2 is towards M2. That is I2. Now you can see, in between direction of intensities are opposite. I1 and I2 are opposite. Anywhere you are taking direction of intensity, you will get opposite. Now when the magnitude of I1 and I2, definitely one point will be there where the magnitude of I1 and I2 are equal. Magnitude of I1 and I2 are equal, not exactly between, it depends on the masses. So I1 and I2, when the I1 and I2 are equal, so they will cancel each other. When they will cancel each other, what is the intensity? You will get zero. Okay. Everybody got or not? So in this case, we will get only one null point in between the masses. Yeah, it will be at the center when the masses are equal. It will be at the mid, exactly mid, when the both masses are equal. So it depends on the masses. Okay. Everybody got or not? Okay. Now suppose I am saying M1 is greater than M2. M1 greater than M2. Then null point will be closer to M1 or closer to M2. If M1 greater than M2, then null point will be closer to M1 or closer to M2. If M1 is greater than M2, then null point will be closer to M1 or closer to M2. M1. One answer we got. M1. M2. M2. M1. M1. Who is saying the answer M1? They are using the concept of the center of mass, because they have learned that in the center of mass is always shifted towards the more mass. I'm not talking about the center of mass. Null point will be always farther from the heavier mass. Null point will be always farther from the heavier mass. Getting or not? I'm not talking about the center of mass. Center of mass is always shifted towards the heavier mass. But here I'm asking about the null point. How we will get this? So we can say what? For null point, I1 must be equal to I2 and magnitude equal, and they will cancel each other, okay, because direction is opposite. I1, what I can write? G M1 by, suppose I am taking from the this distance, I am taking R1, and from here distance I am taking R2. So G M1 by R1 square is equal to G M2 by R2 square. G cancel out. Now R1 by R2, what you got? Under root of M1 by M2. In center of mass, you are getting R1 by R2 is the M2 by M1. R1 by R2 is the M2 by M1. Means M2 more, R1 more. Means mass more, then R1 more means it will be farther from the M1. R1 by R2 is equal to M2 by M1. Means R is inversely proportional to M you are getting in center of mass. Means more mass, distance will be lesser. But here what I am getting, R1 by R2 is equal to root over M1 by M2. Means R1 and M1. M1 more, R1 more. Means more mass, heavier mass, distance for the null point will be more. Everybody getting or not? So null point are from heavier mass. Okay. So result, if you want to remember what the two mass result, so R1 by R2 is equal to under root M1 by M2, you can remember. You will get to the syllabus, you will get today. They will post. I called yesterday night, so maybe they will send today. Okay. Completed. So here I gave the mass of the earth is 81 times of the mass of the Mars. Then we have to find the position of the null point from the center of the earth. So first, who will say the null point will be closer to the earth or closer to the Mars? Null point will be closer to the earth or closer to the Mars? So Earth mass is heavier, Earth is heavier, so that's why null point will be farther from the heavier mass. So it will be farther from the Earth and closer to the Mars. Okay, closer to the Mars. Okay. Now null point position we have to find from the center of the Earth. Suppose this is the center of the Earth, this is the center of the Mars, and null point I am getting suppose at a distance x from the. They are asking from the center of the Earth. That's why from the center of the Earth directly I am taking x. Okay. From the center of the Mars it will be d minus x. Okay. Everybody got or not? They are asking from the center of the Earth, so that's why directly I assume x. I will get the value of x. I will get the answer. Okay. And from the center of the Mars d minus x. Now r1 by r2 is the root m1 by m2. So 1 and 2 we have to decide. So 1 I am taking suppose Earth. 2 I am taking suppose Mars. Okay. Then R1 by R2 means R1 by R2 means x upon d minus x. That is equal to under root M1 by M2. M1 by M2. So this what you have taken? This is the M1, mass of the Earth. Earth 1 you have taken the Earth. So mass of Earth upon mass of Mars. 1 I am assuming the Earth, 2 I am taking the Mars, so R1 by R2 is the root M1 by M2, so mass of Earth upon mass of Mars. Mass of Earth is the 81 times, mass of Earth is the 81 times, so ME is equal to what? 81 times of mass of Mars. Then ME by M, we will get under root 81. Under root 81 you will get 9, so x upon d minus x, that you got root 81, and root 81 is what? 9. Okay, now cross multiply, so what is the x you will get? 9d by 10, or we can say 0.9d. You can check, it is a farther from the Earth. So null point from the Earth center we will get what? 0.9d. Everybody got or not? Okay. Completed. Okay. What is the hard in that? Up to this means one thing, it is a up to this, it is a less, and it is a related with the electrostatics also. I think it is a not hard. Up to this little bit complicated, after that it will be easy also. Because here little bit mathematical it is. Okay. Now what I am saying here, suppose null point everybody got. Okay. If I am saying any spaceship I launch from the Earth, any spaceship I launch from the Earth and towards the Mars, any spaceship or something I launch from the Earth surface to the Mars surface. Okay. Then from here to I am launching any spaceship from the surface of the Earth to the surface of the Mars. So when we require during the, and that spaceship is coming back to the Earth. Okay, you launch one spaceship from the Earth surface to the Mars, and then it is going back from the Mars to the Earth. Okay, so here basically total journey is what? Forward journey and backward journey. So we require more energy or more fuel in the forward journey or in the backward journey. I repeat again, we launch the spaceship from the surface of the Earth to the surface of the Mars. Then again that spaceship going back to the Earth surface. So we require more fuel or more energy in the forward journey or in the backward journey. So now listen, you launch from the Earth surface to the moon, okay, Mars. So what will happen in the forward journey? In the forward journey, what will happen? First, up to the null point. Up to the null point. Listen now. Up to the null point, whose field is more? Earth field is more. At the null point, both fields are equal. So that's why net field we are getting 0. Beyond the null point, whose field is more? Mars field is more. So up to the null point here in the forward journey, up to the null point, Earth field is more. After that, Mars field is more. So you have to launch up to the only null point. You have to suppose it is going from the Earth surface. So it is going to the null point. So it is going against the gravitational field of Earth. When it is launched from the Earth surface and when it is going towards the Mars, it is going beyond the, against the Earth gravitational field. When it reach on the null point, after that it will go in the field of the Mars, because Mars field will become more. So then Mars will attract it by own. Mars will attract it. Okay. So in the forward journey, first it has to go against the Earth gravitational field up to the null point. After the null point, it will get attracted by the Mars. Okay. But during reverse journey, first up to the null point, it will go against the Mars gravitational field. When it reaches to the null point, after that, whose field is more? Earth field is more. Earth will attract it towards itself. Okay. Now you can say in which in which motion it is traveling more distance against the field. So when it is going in the forward, it is null point is far from the heavier mass. Null point is far, so it has to move more against the field of the Earth. So that's why in forward journey it required more energy, more fuel. Why? Because it has to travel more distance up to the null point. So it required more fuel in the forward journey. Getting or not? Or more fuel or more energy, we can say. So next class we will start the G value, G variation and G acceleration due to gravity. Okay. Okay then, bye bye. Yeah, today they will send. Okay.